Hello, geometry students. Today we're going to be going over the Unit 7 packet activity. It's on page 24 and 25 of the Unit 7 packet. So if you can go ahead and open to that, and we'll go over that now. So you're going to need your book to kind of look at the problems, but also which is on page 205 of your textbook, this book. And you're also going to need like a pencil, straight edge, normal stuff. But yeah, the straight edge you're going to need, especially because this unit's all about drawing lines. You're going to want to draw those lines nice and straight. Always use a straight edge for that. Okay. So let me go ahead and share my screen here, and then we'll get started on that. So the page 24 and 25 should look like this. It says, for question 1 here, it says, you want to put tape on the ground to mark the lines for a volleyball court. What is the most efficient way to make sure that the opposite sides of the court are parallel? Okay, so basically they're talking about, if you have a volleyball court, we know that that's a rectangle, a rectangular shape, and we want to make sure that the opposite sides are parallel, so that like this left and right side are parallel to each other, and the top and bottom are parallel to each other. So how do we make sure that that they're parallel? That's basically what we're going to be doing here. Support your answer with a diagram right below how you know how to mark parallel lines for a volleyball court. So what I would say is you would want to take a picture of an aerial view of the area that you're going to make the volleyball court on. So let's say this is my picture of the aerial view. And then we'd overlay a grid on top. So we would have an aerial view. Of where we want the volleyball court. Okay. Then what we would do, so let's say this is our area, and then we'd overlay a grid on top. So you might, with Photoshop or something like that, you can overlay a grid on top. So you'd have like basically graph paper, but you'd be able to see through it ideally. And you can see the ground underneath. So then overlay. A grid over the aerial view. Okay. Now from there, what we would want to do is to make sure that opposite sides are parallel, which is what they're asking. We want to make sure, remember how we find out if lines are parallel? We learned this in this unit earlier, that we know that lines are parallel when they have the same slope. So we would make sure opposite sides have the same slope. Sorry, my writing is, my penmanship is not the best. I'm using a mouse here, but hopefully you could read that, and at least you could hear me say what I was saying. Okay. You might want to add a little more if you want, but basically we would want to calculate the slope. So remember, that's by doing the rise over run on the grid to see if we want to make those opposite sides parallel, Let's go ahead and move on to question 2. It says, in the diagram below, A is parallel to B. So when you see those like two lines, two vertical lines next to each other in this notation, that means that those are parallel. So what they're saying is line A is parallel to line B. So in their picture, we could see this is line A and this is line B. So what they're telling us is that these two lines are parallel. You can see they look parallel for sure. Then it says, what is the measure of angle 4? All right, so here's angle 4 right here. This is what we eventually want to find. And they don't really give us many other angles, but they give us that this angle is 125. Okay, so we might be able to do something with that. So we're going to use this to help us find some other angles. So to help us a little bit, what I want you to do is, you see this little triangle where angle 4 is right here? We're going to go add in a couple more angles here so we can add in like angle, I want you to put angle 5 here and angle 6 here. Okay, so angle 5 and angle 6. Okay, so it might be hard to see there, but that triangle, I'll draw a little bit bigger over here. Here, let's say this is where angle 4 is. You can put 5 right here and 6 right here. Okay, 5 and 6. This is just a zoomed up version of that. Okay, so with using this 125 and the fact that A is parallel to B, so if I just look at, I want to draw A and B over here. And then we have this line cutting across, this transversal cutting across like this. Now we know that this is 125. Okay, now what would be the measure of this angle right here? All right, and I know that's not angle 4, that's actually angle 1, but what would be that measure right there? Hopefully you'd be able to see, oh, well, that would also be 125 because those are corresponding angles. I know it's a while since we talked about parallel lines cut by transversals, right? That was back in the first semester, but hopefully you remember that, or at least can see that those angles are congruent because they're corresponding angles. So we would say the measure of angle 1 equals 125 degrees, comma, because of corresponding angles. For angles, you could write angles, but I usually just write this angle symbol with an S, angles. Okay, so now we know that this is 125. Now we could also find the measure of angle 5 because if we think about angle 1 and angle 5 are kind of like next door neighbors to each other like this. They're on this straight line together, right? So if we know that angle 1 is 125 degrees, then we can figure out the measure of angle 5. Right? Because these two angles form that straight line together, where they're what we call a linear pair. So if you remember, a linear pair of angles, they're always supplementary, meaning they add up to 180. So if we do 180 minus the 125, we'll get 55 degrees. So the measure of angle 5 equals 55 degrees. And we know that because, and I want you to go ahead and finish the sentence, because it's a linear pair with angle 1, okay? Because angle 5 is a linear pair with angle 1. So go ahead and finish that sentence. Okay, so I just don't want to take the time to write that. It takes too long with the mouse. So the measure of angle 5 is 55 degrees because it is a linear pair with angle 1. Okay, so now we know that this is 55 degrees. Okay, now what about, now it also says for lines P and Q to be parallel, what is the measure of angle 4? So in order for these to be parallel, so let's pretend these are parallel, which basically they're saying that we want to kind of pretend, we want to kind of assume that they're parallel is what they're saying. So if these are parallel, then we can say that this is a right angle, but also so is angle 6, right? So, and those, if we look at the lines P and Q, and then cut like this. And we know that this angle right here was a right angle. So then this angle would be also, right? That's where angle 6 is. And those are what we call alternate interior angles. So we would say the measure of angle 6 equals 90 degrees, comma, because alternate interior angles. Okay, so you would write measure of angle 6 equals 90 degrees because of alternate interior angles. Okay, so now we can update our picture over here. We know that this is 90. Okay, now with that in mind, now we can figure out the measure of angle 4. Because remember, the three angles within a triangle always add up to 180. So if I know two of the angles, I can figure out the third. So let's go ahead and do that. So what would the measure of angle 4 need to be so that the three angles add up to 180? $35 degrees. So then we would say the measure of angle 4 equals 35 degrees, comma, because, and again, you should complete both of these sentences. These should both have like a comma, because, and then an explanation, okay? And I explained that what should go there. But here, same thing. So the measure of angle 4 equals 35 degrees because why? Well, because the three angles in a triangle add up to 180. So that's the triangle angle sum. Okay. All right. I hope that makes sense. I know I did a lot of drawing here. Okay. Last one. Use the space below to answer the performance task on number 3 on page 205. So here, if we look on page 205, so hopefully you have your textbook open to that. If not, I'm going to go ahead and read it here. The problem isn't written here, so I'm going to go ahead and read it. It says AB, line AB, contains point A, which is at -6, -1. I'm going to go ahead and graph that already. So point A is at -6, -1. So 1, 2, 3, 4, 5, 6, -1. So this is where A is. So this is point A. And B is at 1, 4. So 1, 1, 2, 3, 4. So B is here. And it says that's a line. So we're going to go ahead and draw this line connecting these 2 points. So hopefully you have a straight edge here. You can draw a nice straight line. Mine's not going to be perfect because I don't have a straight edge. But that's not too bad. Okay. Pretend that's a straight line. Okay, now it says we have another line, line CD. It contains point D, which is at 7, 2. So I'm going to draw a point D, 1, 2, 3, 4, 5, 6, 7, 2. This is where point D lives. Okay, let me make sure I counted that right. Yeah, okay. If angle ABC is congruent to angle BCD, and the measure of angle ABC is 90 degrees, what is the equation of line CD? Okay. So basically it says the measure of angle ABC and the measure of angle BCD are both 90 degrees. So if we imagine A, B, and then there's a connecting point C somewhere, okay? Now C will make it so that this will be a 90-degree angle. So C, if we look at, let's take a look at, for example, the slope of line AB. This is going to be a key. So if we look at the slope of line AB, we're going to look at the rise over run, right? So the slope of AB, so I'll write M, usually M is for slope. So, and I'll put AB kind of underneath. So you know that I'm talking about the slope of line AB and not the slope of CD. Okay, so the slope of AB is, what's my rise? 1, 2, 3, 4, 5 over run. 1, 2, 3, 4, 5, 6, 7. So 5/7. So that's the slope of line AB. Okay. Now we know that line BC is going to be perpendicular to it, right? Because they're going to cross at a 90-degree angle. That's what it says here, that the measuring angle ABC should make a 90-degree angle. So C's got to be such that, like maybe like here-ish or something, where ABC will form a right angle. Well, C could be up here too, right? Because that'll form a right angle here as well. But basically, we need to create a line that's perpendicular to this one. So, and goes through point B. So let's go ahead and do that now. So if the slope of AB, then we can figure out the slope of BC, because BC is going to be perpendicular to that. So that's going to be -7/5. Remember from this unit, for perpendicular lines, meaning they cross at 90-degree angle, perpendicular lines, they are opposite signs, so one positive, one negative, and they're reciprocals of each other. So if this one's 5/7, this one's 7/5. So it's the opposite reciprocal. So from here, we can go down 7 over 5. 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4, 5. So I don't know if C is right here, but I know that the line containing C has to go through that point. Okay. So this is not necessarily where C is, but I know C is somewhere on this line. That's kind of the key. C is somewhere on this line because this needed to produce a right angle. Okay. Okay. Now it says BCD is also a 90-degree angle. So BC, C is somewhere on here, to D will also form a right angle. So we know C needs to be somewhere where we did BCD, it would form a right angle. So in other words, the line that we make here needs to be perpendicular like that. Okay. Now, what does that tell me about DC and AB? That tells me that DC and AB must be parallel to each other because they're both going to be perpendicular to this BC. Okay. So if I know the slope of AB, which I do, then this will also be the slope of DC. Okay. So the slope of AB is going to be the same as the slope of DC. So if I know where D is, I can find where CD will go through, right? So notice the slope here was 5/7. So if I go down 5 and to the left 7, I should be able to create the line. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay. And so if I connect that, that'll create my line. And where's point C? Is this point C? No, point C is where it crosses. So point C is where this forms a right angle like this. Okay, so there's line DC. And now it asks, what is the equation of DC or CD? So we know its slope is 5/7. And when we think about writing an equation of a line, it's y equals mx plus b. M is the slope. So if we're looking at line CD, then it would be y equals, well, what's going to be the slope? That's 5/7, right? So this CD has a slope of 5/7. Plus b is the y-intercept. So what's our b in this case? Well, our b is -3. So I'm going to, instead of putting a plus, we'll do, say, -3. Okay, so this would be the equation of line CD. Okay, So if you followed along and you had your straight edge, you made it look really nice, hopefully you get something that looks like this, and this will be your final answer for the equation of line CD. All right, and that's it. I hope that made sense. I hope you're able to get through it without too much trouble. If you still need help, you could always email me. It's my email is ttrigg@ofy.org. In other words, trig with two G's at ofy.org. All right. Well, with that, I'll see you guys next time.